All right, in the previous video we showed how we pull data out of Pulse. Ultimately that data ends up in a timer routine that gets triggered 10 times a second. That routine pulls the highest values out of Pulse that have occurred during the previous tenth of a second, puts them into a vector, and queues up 3 drawing routines, or 3 drawing signals. One of the drawing signals does the meters. Another one does the displays up here in the box in the upper left, and a third one does it in this graphical area here, which we're not at the moment talking about. Okay, the meters, that's what I'm going to talk about today because they're the simplest ones. The meters, before I get down to the details, we've got 2 types. We've got the digital meters, which you see the microphone working. There's nothing playing, so you're not seeing anything in the sound. We get the VU form, which looks like this. It doesn't have a microphone, but it does have the left and right. They're not labeled left or right, I just noticed that. But anyway, you probably guessed which is left and which is right. All right, the difference between the 2 meters, one of which is the baseline is different. You see on the left meter, it's all the way horizontal in the 0 position, and the right meter is all the way horizontal. When you go to VU meters, it's not all the way flat down. It could be, but it's not. Most of them look like this. They have a pin here that prevents them from going any further. But anyhow, that's the physical meter. This is not physical, of course. All right, and the meters only go up a certain point, whereas in the digital meters they could go all the way up to the end there, completely back to horizontal. All right, so there's differences there in the VU meters. Let's start some music here. Hopefully I've got the music clamped so it's not going to bother you. It's random music, so they're not going to... YouTube won't claim it. Well, they may, I don't know. But you can see the meters jumping around as it's listening to the music being played, which apparently is there. All right. If I go back to settings here, if I go to meter arcs, you see this type of display, these fan arcs. If I turn off, with VU meters on and you go to meter arcs, you see this. With VU meters off, you see those. They're also arcing, they're smaller fans, but similar. All right, so there are our meters. That's what they look like. In terms of where is this point up here, where do we determine what's maximum and optimal? It's not really the same in digital. What I do is I pick the point at which it declares something is clipping by seeing what OBS thinks it is. So these are the points. I've calibrated it so when it gets up into the red zone here, that's where OBS is getting into the red zone. And if I bring up OBS here, you can see it as I'm speaking. You can see it's drifting into the red, but if it really went red, both bars would go red. So I'm using this point right about here in OBS. Actually, I'm using it for here. The clipping is only detected on the playback. And the playback is clamped, as you can see, but if I were to raise it up, it's possible. But it won't. This area here corresponds to this area in OBS. It was tuned for that purpose. All right, let's kill the music, kill the program, hold all, and we get rid of the graph page, and we can get rid of that. We can go to settings. All right, so we're going to talk about the VU meters. The VU meters are easier, they're simpler, they're not the other meters there's lots of things. There's all these hash marks are illuminated. There's this root mean square, the larger box, the narrower box is the maximum. There's more going on, but it's essentially the same thing. So I'm going to do the VU meters. They're simpler because there's only a needle. Very simple, just a needle. Okay, where does this show up on the Glade? Well, it shows up draw 2. This is draw 2 down here. That is where the meters go, all of them. They're all drawn in that drawing area. Now, above them here is VU meter 1 and VU meter 2. Those are images. Those are pictures. What are they pictures of? They're the background. So if you're running the traditional VU meters, these images are being shown, and you're seeing that static background of a VU meter. Draw 2 is on top of it, and the needle will be swinging back and forth on top of that graphic. When you're in digital mode, these two images are turned off. You don't see them, all right? And you only see the other meters, and they're drawn completely. They're all entirely digital. Whereas with the VU meters, you see the static backgrounds, and you see a needle being drawn across them. So that's where we are. All right, get that off the screen, and we can go back here. All right, in the timer, I queue up, as I said, 3 drawing signals. Draw 1, draw 2, and draw 4. This is draw 2 we're talking about. And here's where the signal is picked up. Now, the question is immediately, which meter are you doing? Are you doing the digital meters, or are you doing the traditional VU style? And there it is. We're doing the VU style, so I call this function von draw 2. Very cleverly, VON instead of, anyway. And let's find that. So this is what gets control during a draw of draw 2, if you're doing the traditional meters. Now, the traditional style, by the time you're here, the backgrounds have already been turned on. They're only turned on once. They don't have to be turned on multiple times. Okay, so you come on down here. The first thing I do is I average the, in the case of Linux, the last 3 items in the vector. This is to prevent, to get a value, and that value is going to be the one that's used to move the meter. The purpose of that is to keep the meter from getting too jiggly. Real meters are real. They have momentum. They're ballistic. They don't jiggle all that much. And so, you can tune this to decide whether you like it or get rid of it or whatever. But the last 3 values are averaged in order to get a left and right value, and this will be the value that moves the meter, all right, for left and right. Next, I determine if it's clipping. There's a clip level, which is set someplace else. I believe it's 80 is on the screen, but I think it's 0.8 internally. Anyway, the clipping signal is turned on if it is, and that's used, not used very much. It's not used in this particular routine, but other routines can see this value. The AGC can see that it's been turned on. AGC also tested. It's tested in various places to see if the audio is too high. So that's the left clipping. There's also a right clipping. The left and right are almost identical. The only difference is one's got an L in it and the other's got an R's in it. Okay, LX is the value. If it's greater than 0, then I'm going to scale it. So in other words, it's usually 0 to 100-ish. So if it's, so I scale it from 0 to 1 and multiply it times pi. So occasionally you get negative values out of Pulse. I don't know why. But for some reason, if it's 0 or less than 0, it's set to 0. All right. What's this business with pi? Well, in the meters, let's bring up the meter again here. And let's bring up the base meters because they're a little more clear here. Okay, this is the spindle on the left. This point over here, the arc goes up from the left towards the right. This point in the arc is minus pi. This point in the arc over here is 0. The arc could go underneath, and it would go from 0 to plus pi. Okay, so this is how Cairo draws. It goes from, so we're going from, it's sitting at minus pi right now. 0 is minus pi. Well, the 0 value coming in sets it to minus pi. When it's 100%, it's set to 0. All right, for purposes of drawing. So I come down here and I get the value T1, or excuse me, LX is the value between, after this multiplication, it's between 0 and 1. 0 means there's no audio. It's all the way to the left. 1 means it's full audio. It's all the way to the right. All right, so I multiply it times pi. So if it's no audio, the value will be 0. If it's full audio, the value will be pi. MPi is a built-in Linux include file that's got all these symbols for pi and for other things. So that's pi carried out to some large number of digits. So if the audio level is 0, the value of T1 will be 0. If the audio level is 100%, the value of T1 will be pi. All right? What happens is I add this value to minus pi. So if it's 100%, in other words, it's pi, I add it to minus pi, and I get a 0. What does a 0 mean? It means to put the needle all the way to the right. All right, so it's kind of backwards, but not that far. All right, that's the, then do the calculation there. So T1 tells us where to go. It's from 0 to pi is what it's going to say. And it actually, when it gets added in, we're going from minus pi to 0 internally, but it starts off 0 to pi. It has to start someplace. All right, where's the center point of the needle? And the horizontal, vertical, and the length of the needle are calculated here. If you decide to move things, this is where you would move them. I don't know why you would, but if you do, this is where you're going to do it. If you decide to put a different background up and you want the center of the needle to be different, this is where you'd come to fiddle with it. Okay, then we call a function called VNeedles, VU needles. And it's done the same. You can see the right channel right below. It's identical. We pass down CR, which is the pointer to the drawing surface, the horizontal, vertical of the origin of the needle, the center point, the length of the needle, where the needle's supposed to go, and an indication of the color. Because this, the routine we're calling, will also do the fan arcs. And you have to tell it what color you want. So 1 means yellow, and 2 means red. All right? So we call VNeedles. And let me, whoops. Find it. All right, here's VNeedles. This is the function. It's the same function for both left and right, because the only difference between the two of them is where the origin is, or in the case of the fan, the color. All right, we come down here, and we, I don't know, that's an adjustment that got thrown in there years ago, and I don't know if I should remove it or not. It's not hurting me, and I know if as soon as I remove it, something will go wrong. Anyway, it probably should be removed. But T1 is greater than pi, I make it pi. So in other words, that gives me an upper limit, pins, that's as far high as you can go. Let's see, set the line width, so that's pixels. Park, because these are the meters that don't go all the way flat. The parking point is on the left-hand side, how far above the horizon it is when it's idle. The max is 0, which is the far end. Okay, so we get two forms. We've got show arc. It means to show arcs. So if it's not show arc, we're here. So we're going to do in other words, right now we're doing regular old VU meters with black needles. Okay, and that's not show arc. Cairo, set the needle to be black. The other needles have colors. Let's see. Okay, T1 is equal to park plus T1 times 0.77. Since T1 is really intended to be for the, from horizon to horizon, it's from 0 to 1, the whole scan. But the VU meters don't go all the way up. They start, so going back to the appearance of the VU meter, they don't go all the way down. They start here above the horizon. And they don't go all the way down over here. They max right about here, okay? So there's a limit to them. So the range of the VU meters is different. And that's what I'm doing. I'm scaling for the range. And trial and error, it's 0.77 times T1 will give me a range which will put me in that vicinity. Park is the bottom end. So it's park plus whatever the value is for where you want to put the needle. Oops, these are things that should have been deleted. They're old code. You'll see old code like that. When I try something out, I comment out the old code before I completely delete it. And that was a residue. Okay, the right extent. This is the thing that's going to be, let's look at the Cairo arc function. There's the drawing surface, there's the center, there's the length, there's the left-hand part of the arc, there's the right-hand part of the arc. And that's what we're looking at here. Left-hand part of the arc is all the way over to from the arc starts at minus pi and goes up to right extent. Whoops! I hit a character that didn't do and caused an insert. Anyway, so right extent is minus pi plus T1. So this is where the needle is going to go. It's going to go minus pi is flat all the way to the left. Plus T1 is a value lower than, higher than minus pi. It's getting up towards 0. T1 is a positive value. It's a positive value between 0 and pi. When it's pi, we want to be all the way, so to speak, to the right. And when it's 0, we want to be all the way to the left. All the way to the left for T1 means 0.3. That's the parking point. All the way to the right, it won't go all the way to the right because that 0.77. So anyway, we reduced it. So that's the other extent of the arc. And the arc it starts at the very right-hand side and goes up. Nothing's been drawn here. We've just created an arc going from the left-hand side up to some point across the semicircle. And right extent tells it this is the left horizontal. This is someplace up on that arc. That's what we did there. Okay, we get the coordinates of that point where the arc is. All right. So what I've told it is to draw to envision an arc. It hasn't actually drawn anything yet. Envision an arc with the needle and the point of the needle. What I'm getting back is the point of where the needle is on the arc. Okay, X and Y, notice I'm passing addresses. I get back the values, which are floating point, double precision. It gives me where on the arc that point is for T1. All right, and then the new path basically wipes out the arc because I'm not going to draw the arc. Otherwise, I'd be drawing a circle, or half circle, or quarter circle, or whatever. So new path, move to X and Y. Draw a line from the horizontal vertical to X and Y, stroke it. That causes it to actually be drawn. All right, so you get the point here, is that we came down, we calculated where we want T1 to be. It's park plus some value. That value, where that value T1 is between 0 and pi, we reduced it in order to scale it. We give it a minimum, basically, of park. Then we draw an arc from the horizontal extent of the horizontal to the left, all the way up to some point that T1 represents. And then we grab that point, and we use that point in order to actually draw the line. That's where the line is actually drawn. So you'll notice that right extent, this is the key, it's minus pi plus T1. So if T1 is, T1 came down as 0, T1 will be 0.3, because that's the park. And that would mean minus pi plus 0.3, which would be a little bit above the left horizon. If T1 came down as 100, it would be 0.77 plus park, which is going to be real close to pi times plus pi. T1 doesn't come down as 100, comes down as pi. So 0.77 of pi plus park added to minus pi, we're going to get a value closer to 0. 0 being the other end of the arc. I'm gesturing here, and I know you can't see me, but in the arc, this is the low point here. Minus pi is down here. This is minus pi plus 0.3. If we came down with the maximum value, it would be minus pi plus some value, which gets it close to 0, because this is 0 down here. This guy down here is the 0 point, and that's how it works. And we draw the line. So when I tell it to play beautiful music, randomly created, the thing starts bouncing around. And it's dampened a bit, so it almost looks real. You tried putting a shadow in. I tried. It didn't look all that good, but you can play with it. But anyway, it looks fairly convincing as a needle. So that's how at least one needle is done. The other needles are done really the same way, but it's just more of the same. There's more detail, and there's more arcs, and there's the other one down here is the show arcs, which is essentially the same thing because it goes horizon to horizon. So we don't have the park or anything like that. There's where the color is selected: yellow for 1, red for 2. Let's see. This goes up in this one here. There's an arc from minus pi to minus pi plus 0.2 0.05. That gives you a tiny little line. That's the line you see when everything's idle. And when we go through here, we go from 0 to T1 by increments of a tenth. All right. What that does is draws each of those individual fans. I'm not going to get into the details, but that's each of those the starting points of each of the individual fan plus 0.5. That's the width of each fan. So the fans are, that's how the individual spokes are drawn. But it's the same idea. And then there's a spindle down here, which just basically draws a circle and fills it in. All right. I hope that made sense. It made sense to me, I think. Thank you.